Good day, students and teachers. My name is Omer Deborah, and welcome to my YouTube channel. I am an education student of LASU, studying physics education, and today I'm going to be tutoring you briefly on gas laws. Please like and comment.
Okay, so firstly, what is a gas? A gas is basically a state of matter that has no fixed volume, no fixed shape. Its particles are widely spaced, and it has low density with high compressibility. Examples of these gases can be air, it can be oxygen, it can be nitrogen, it can be hydrogen, and so on. What are properties that can be described, or what are properties that can describe a gas? Gases are described by three basic properties known as volume, pressure, and temperature. There are several subtopics under gas laws. Gas laws has the topic gas pressure measurement. It has Boyle's law. It has the Charles law. It has the pressure law. It has the general gas law, and so on. But today I'll be basically teaching us on Boyle's law, Charles law, pressure law, and the general gas laws. Okay, so first we're going to start with the Boyle's law. The Boyle's law states that the pressure of a fixed mass of gas is inversely proportional to the volume, only provided that the temperature is kept constant. Okay, so more clearly now, the Boyle's law states that the pressure of a fixed mass of gas is inversely proportional to the volume, only provided that the absolute temperature of that gas is kept constant. Mathematically, it's represented that the pressure P is inversely proportional to the volume. Then P equals constant K, or constant temperature, over V, which gives us the P pressure times the volume is equals to the constant temperature. Then we can say the initial pressure and the initial volume is equals to the final pressure and the final volume. We can be given a question that we should find P, X, V, Y, and T, Z. That is, we should find the value of those X, Y, and Z. How to do this is from here, P equals to T over V. Okay, so P equals to T over V. P has the power 1, V here also has the power 1, and equals to T, which has the power 0. Okay, so and T is equals to 0. Then P with the power 1, V the power 1 divided by T when you cross multiply equals 0. Then P to the power 1, V with the power 1, T to the power 0 equals 0. Therefore, the X, Y, Z, the values for the X, Y, and Z is 1, 1, and 0. Moving on to Charles' law. Charles' law states that the volume of a fixed given mass of gas is directly proportional to the absolute temperature, provided that the pressure is kept constant. So mathematically, that is, the volume V is directly proportional to the temperature T. That is, V equals the temperature T and the constant pressure. Then V all over T is equal to the constant pressure. Therefore, the initial volume over the initial temperature is equals the final volume over the final temperature. So like we did in the Boyle's law, they can ask us to find the Vx, the Ty, and the Pz. Like we did at the with the Boyle's law, we can repeat the same process, saying the V over T equals pressure, V with the power 1. When we take the temperature up, the power is going to turn to -1, as we all know from our math. Then the pressure is raised to the power 0. That is V power 1, T with the power -1, all over P with the power 0 equals 0. Then V with the power 1, T with the power -1, and P with the power 0. So our X, Y, and Z values equals 1, -1, and 0. Our first example here, the volume of a fixed mass of gas is 40 centimeter cube at 1007 millimeter mercury. Calculate the new pressure at 48 centimeter cube. So our formula for Boyle's law is PV equals T, that is initial pressure, initial volume, final pressure, final volume. So the parameters given, the V1 equals 40 centimeter cube, the pressure 1 is 1007 millimeter mercury. Our final volume is 48 centimeter cube, and we are looking for our final pressure. We are going to make the final pressure the subject of formula, that is P1 V1 cross multiply, V comes down to here, and that's our pressure. So fixing in the values, we have the P1 as 1007 times our volume 40 all over our final volume 48. So that is and we see the 1007 multiply 40, 1007 multiply 40 equals, that's 40,280 divided by our 48 equals 839.2, approximately 839.2 millimeter mercury. Okay, so Moving on to our Charles law. Charles law. Question 1. So, Charles law. Dry oxygen is trapped by a pellet of mercury in a uniform capillary. In a uniform capillary tube, which is sealed at one end, the length of the column of oxygen at 27 degrees Celsius is 50 centimeters. If the pressure of the oxygen is constant, at what temperature will the length be 60 centimeters? Q and Q because it's volume. Okay, so using our Charles law formula, V over T equals the constant, initial volume over initial temperature equals the final volume over the final temperature. So our parameter says the V1 is 50 centimeter cube, and our first temperature equals 27 degrees Celsius. Temperature, the unit for temperature, we use our temperature in Kelvin. So this 27 degrees Celsius, we are going to convert it to Kelvin. That is, we add 273 Kelvin, which equals 27 plus 273 equals 300 Kelvin. So our first temperature is 300 Kelvin. Our final volume is 60 centimeter cube, and our final temperature is what we are looking for. So we're going to make the final temperature the subject of formula, cross multiply, that is V1 T2 equals V2 T1, then T2 equals V2 T1 all over V1. Therefore, the T2 equals our V1 is 50. Our V2 is 60. Our V2 is 60. Multiply our T1 300 all over our V1 50. 0, 0, 5, 6. That is 360 Kelvin. Okay, so we've come to the end of today's video. Please check the next video for further topics on gas law